Hello everyone. Today I'll be talking on Wireshark and I'll be conducting a demo using Wireshark. So firstly, what's Wireshark? Wireshark is a free and open source protocol analyzer. And what's a protocol analyzer? A protocol analyzer is a software tool that allows for the capture, reassembly, and analysis of packets from the network. And Wireshark is used for network troubleshooting, analysis, software and communications, protocol development, and education. So in Wireshark, we have different ways we can bring in data or capture network traffic. First, we can do this. We can set the protocol analyzer to promiscuous mode, which means the network adapter is able to capture all of the packets on the network, regardless of the destination MAC address of the frames carrying them. We can also set it as non-promiscuous mode, which means the network adapter can only capture the packet addressed to itself directly. We can also use physical devices such as a network tap. A network tap is a physical device that allows you to intercept the traffic between 2 points on the network. So now let's go over to the Wireshark's GUI. I'll be demonstrating and showing some things we can do with Wireshark. Okay, now we're on the Wireshark's GUI, and the first screen that we are greeted by when opening Wireshark is the main page that will allow us to specify our interfaces as well as apply filters to narrow down the traffic we are capturing. And here you can see I have multiple interfaces to filter from, and from here we can also choose whether we want to perform a live capture on our interfaces or load a packet capture file for analysis. If you want to load the packet capture file, what I'll be doing soon. So we can just click file, open, and yeah, if we have existing packet capture files, then we can load it from there. Also, any of all the interfaces, any bar that is flat, it means that it will be useless to capture on it, as like no data on that interface is being picked up by the Wireshark's client. Okay, I'll just click on my local area connection interface because that's what I'm to use to capture network traffic right now. So yeah, as you can see, soon start capturing some traffic and it will display here. Okay, some traffic has started to enter, and I can use this stop sign to stop the capturing for now. So I'll just leave it to be capturing for now, and I quickly want to talk about something here. So yeah, filtering operators. Wireshark only has a few that you need to be familiar with, and that's the AND operator, the OR operator, the equals operator, a not equal operator, and greater than operator, and the less than operator. So I brought this up because I'll be using it to filter very soon in the video. So it's just to have an idea of this. And also, I want to talk about packet dissection. So packet dissection covers how Wireshark uses OSI layers to break down packets and how to use these layers for analysis. So, for example, maybe I click on this packet now. As you can see, we have frame, Ethernet protocol version transmission control protocol. So let me just talk about the ones that are displayed here. So first of all, frame. This will show you what frame or packet you are looking at, as well as details specific to the physical layer of the OSI model. And we also have the Ethernet, which is next. So Ethernet belongs to layer 2, and this will show you the source and destination MAC addresses from the data link layer of the OSI model. So as you can see, this is the source right here, SRC, and this is the destination. And next we have the Internet Protocol version, and this is layer 3. This will show you the source and destination IPv4 addresses from the network layer of the OSI model. And we also have the layer 4 protocol here. This belongs to layer 4. And this will show you the details of protocol used. If it's UDP or TCP, here we can see it's TCP, transmission control protocol, along with the source and destination ports. So this is the source port, this is the destination ports, and it's from the transport layer of the OSI model. So it basically just shows the packet details, and you can double click on a packet to capture to open this. You can double click on a packet in capture to open its details. So packets consist of 5 to 7 layers, like I said, and they are based on the OSI model. Right now I don't have any HTTP traffic, but I will analyze HTTP packet capture file soon, and you see that there are more packet details that can be gotten from the HTTP capture. So I'll just stop the capturing for now. And the first type of traffic I want to analyze is the ARP traffic, that's ARP. And ARP stands for Address Resolution Protocol, and it's a layer 2 protocol that is used to connect IP addresses with MAC addresses. And they usually contain request messages and response messages. And to identify packets with the to identify packets, they usually we use operation codes. So 2 operation codes and requests or reply. So I have a Linux machine that I've started up here. So I'll be using it to send ARP traffic over the network. So for that I need to listen. Let me start my capture with Wireshark. Let's see what to say. So yeah, so I just use mmap to send ARP traffic, and let me send for the network range. But before let me just show the IP address for this machine. Okay, this is the IP address .8, while my Windows machine is .6, but you'll see when I send out the traffic now. So nmap. I will use the SN to skip the port scan, and we use the PR to send out the ARP traffic. So I hit enter. So I go back, and I can just stop this. Search for the ARP traffic. As you can see, this in looking kind of brown. So these are the ARP traffic on the network. Okay, we have a lot of capture here, but we can just easily filter to display just the ARP packets. Okay, so we can begin by analyzing an ARP traffic by first looking at the ARP request packet and looking at the packet details. So as you can see from here, if I should open this, I talked about the op code, the operation code. So we can tell that this is a request packet, and let me just look for a reply. Okay, this is, as you can see, the op code. You can see that it's a reply packet. We can get useful information like the MAC address and IP address that was sent along with the reply. So this is it here. This is the IP address of my Linux machine, as you know, as we checked earlier. And 10.0.2.6 is the IP address of my Windows virtual machine, which is where Wireshark is running. So the next type of traffic we'll look at now is the ICMP traffic. For that, I can just start to listen again, and I go back to my Linux machine, and I just ping. Let me ping my Windows virtual machine. Okay, so I can stop this now. That's enough. So ICMP stands for Internet Control Message Protocol, and it's used to analyze various nodes on the network. And it's commonly used with utilities like ping, which I just did, and traceroute. So let me go back to my Wireshark and check. Oh, I'm sorry, I didn't clear this. Um, okay, so this in pink, these are ICMP. As you can see, the protocol, not the protocol, we see ICMP request. And for ICMP request, we are there are a few things that within the packet that we need to take note of. And the first being the type and code of the packet. A type that equals 8 means it's a request packet, and if it's equals to 0, it's a reply a packet. So when these codes are altered or do not seem correct, that means that that's a sign of suspicious activity. So um, I can just click on any one of these, and this is the protocol right here. So this is a type of 0, which means it's a reply packet. And here we see the type is 8, which means it's a request packet. So there are two other details that within the packet that are useful to analyze for ICMP, and that's the timestamp and data. So here's the timestamp. The timestamp can be useful for identifying the time the ping was requested, as you can see. And it can also be useful to identify suspicious activity in some cases. The data string, we can also look at the data string, which will typically just be a random data string, which is this right here. So that's it for ICMP traffic. And the next traffic I'll be going on to is TCP traffic.